after this lesson, students will be able to evaluate and simplify algebraic expressions by following the order of operations and combining like terms. Important vocabulary for this section are variables, algebraic expressions, and evaluate. Variables are symbols, usually letters, that represent numbers that are unknown or changing. Algebraic expressions are statements that include numbers, variables, and operations, which are addition, subtraction, multiplication, and division. Algebraic expressions do not have equal signs. If they do have an equal sign, it would then be called an algebraic equation. When you evaluate, you find the value of an expression after substituting numbers for variables and then simplifying by using the order of operations. Try the two questions at the bottom of the screen on your own. Pause, and once you've finished, you may resume. Number 1, -4 squared. For this question, only the 4 is being squared. And then we're taking the opposite, -16. Number 2, 20 minus 4 plus 6, the answer is 22. If you said 10, you'll see in a couple of slides why you made a mistake when following the order of operations. Order of operations, please excuse my dear Aunt Sally, or PEMDAS, is often mistaken for being 6 steps, when in fact, you should think of the order of operations as 4 steps. Step 1, you always do parentheses. Step 2, you always do exponents. Step 3 is multiplication and/or division. Whichever comes first from left to right is the one that you need to do first when solving. Step 4, addition and/or subtraction. Again, whichever comes first from left to right is the one that you need to do first when simplifying your algebraic expression. Try these questions, so pause and resume when you're ready. Number 1, -2 squared is -4. Number 2, since the -2 is in parentheses, I am raising -2 to the second power. -2 times -2 gives us +4. Number 3, -2 to the third. 2 to the third is 8, and I'm taking the opposite, so -8. Number 4, I'm raising -2 to the third power. -2 times -2 times -2. Well, -2 times -2 gives us +4, times -2 gives us a final answer of -8. Number 5, -2 to the fourth, -16. And number 6, the quantity of -2 raised to the fourth power would be +16. A shortcut when looking at questions where the negative integer is in parentheses and being raised to a power is that when you look at the exponent, if it's an even exponent, it'll give you a positive answer. And when you have an odd exponent, you'll end up with a negative answer. Simplifying numerical expressions. For these, you'll have to follow order of operations. I suggest showing each and every step in an organized manner. I like to circle each step as I go. 25 minus 8 times 2 plus 3 squared. I first ask myself if there are any parentheses. Since there aren't any, I move on to the second step, which would be exponents. This question does have an exponent, so I circle 3 squared. 3 squared is 9, and then I recopy the rest of the question. Next is multiplication and division from left to right. I multiply 8 times 2 to get 16 and recopy the rest of the question. Next is addition and subtraction from left to right. 25 minus 16 is 9. plus 9 gives me a final answer of 18. Pause the screen to try the following two questions, and when you're done, you may resume. Simplify -8 plus 5 times the quantity of 1 minus 3 to the third power plus 5. I start with parentheses. 1 minus 3 is -2. That quantity is being raised to the third power, so I need to leave it in parentheses. I recopy everything else. Next, I'm going to do my exponent. -2 to the third power is -8. Since there's no operation between the 5 and these parentheses, I am going to be multiplying. So I'm going to leave my -8 in parentheses. I'm recopying the rest of the question. Next comes multiplication. 5 times -8 is -40. Recopy the question. And then addition and subtraction from left to right. -48 plus 5 gives us our final answer of -43. Number 2 has more than one set of parentheses. We start with the innermost parentheses, and we follow order of operations within the parentheses as well. So I'm going to start with 5 squared, which is 25, and recopy the rest of the question. Next, I have to finish what's in those parentheses, the innermost parentheses, so 25 times 2 is 50. Next, 10 plus 50, and 60 divided by 6, which is 10. Evaluating algebraic expressions. For these, we substitute and compute. Substitute. You may know this word from our everyday language. Substitute, like a substitute teacher, means to replace something. So you're like replacing your classroom teacher with a substitute teacher, or subbing in a player in a basketball game. In algebra, it's when you replace a number with a variable. Compute is another word for simplify or evaluate. Example 1. Evaluate 7x minus 3xy when x equals -2 and y equals 5. Since x equals -2, wherever I see x in the algebraic expression, I can put -2 instead. And since y equals 5, wherever I see y in the algebraic expression, I can put 5. 7x means 7 times x, so I'm going to put my -2 in parentheses, 7 times -2, minus 3 times -2 times 5. I now simplify this by following the order of operations. Multiplication and division from left to right. So -14 minus 3 times -2 times 5. Next, I'm going to do -2. By circling this negative or minus, I'm ensuring that I won't forget about it. -14. This would now be +6, I do have to put the plus sign there, times 5. Now I'll multiply 6 times 5, so -14 plus 30, which gives us our answer of +16. Try the next question on your own, so pause the screen and resume when you're ready. Evaluate k minus 18, all raised to the second power, minus 4k when k equals 6. So I substitute in 6 for k. I start with my parentheses. 6 minus 18 is -12, and that is still in parentheses because that quantity is being raised to the second power. Next is exponents. Negative 12 raised to the second power. Since both the negative and the 12 are being squared, I get a positive 144 minus 4 times 6. Now, I can choose to include my negative sign or leave it as a minus. In this case, I'll just circle the 4 times 6 and get 144. Now I have to write my minus sign, 24, and I get 120. Try these 3 questions, so pause, and when you're ready, you may resume. Evaluate each expression when r equals negative 6 and t equals 3. r is negative 6, and the t, or 3, is being squared. I then follow order of operations, so 3 squared is 9 times negative 6, which gives a final answer of negative 54. Part B, the r is being squared. Since r is being squared and r is negative 6, negative and 6 are both being squared, so I need to put it in parentheses. And that is being multiplied by t, which is 3. Following order of operations, I start with exponents. Negative 6 times negative 6 is positive 36 times 3, which gives an answer of 108. Part C. In parentheses, I have r times t, negative 6 times 3, all squared. I start within the parentheses and get negative 18. That entire quantity is being squared, and we get an answer of 324. The distributive property is very important in algebra. An algebraic expression in simplest form has no grouping symbols, which means no parentheses. In order to get rid of the parentheses, we're going to have to do distributive property, because what's in the parentheses we cannot combine since they are unlike terms. Try these questions on your own, and when you're ready, you may resume. Whenever I see a minus sign, I like to circle it along with the term so that it reminds me to treat it as a negative, and so I don't lose track of it. I can then distribute the 2 to the 3 and to the negative 7t. 2 times 3 is 6, and 2 times negative 7t is negative 14t. For our final answers, we'll use the standard form of a polynomial, which states that we go from highest degree to lowest degree. So our final answer is negative 14t plus 6. Part B deals with fractions. I'm distributing 1/4 to 4x and to 20. I can treat 4 as 4 over 1 and 20 as 20 over 1 to help. 1/4 times 4x over 1. I can cross reduce, so I get x. 1/4 times 20 over 1, cross reduce, and I get 5. So x plus 5 is our answer. For part C, we distribute in the 5, the whole term, to both 4w and 6. So we get negative 20w minus 30. Part D, again, I like to circle the negative so I don't lose track of it. And then I distribute to get negative 24 plus 6x, which in the standard form of a polynomial is 6x minus 24. Using the multiplication property of negative 1. These look like distributive property, except the factor in the front is just a negative sign. You can think of it as -1 and distribute -1 to each term in the parentheses. Essentially, you're taking the opposite of each of the terms. So we get -6x minus 4. Try the next 3 questions, so pause the slide, and when you're ready you may resume. Number 2, -2x minus 1. Number 3, +4y plus 6. Number 4, -8 plus 5z, which in standard form is 5z minus 8. Some important vocabulary regarding polynomials. This polynomial has 4 terms. A term is a number, a variable, or the product of a number and variables. A constant is a term that has no variable, like the -12 in this example. And the coefficient is the numerical factor of a term, or the number that comes right before a variable. Like terms are terms that have the exact same variables raised to the exact same power. Pause the slide and try these 4 questions, and when you're done you may resume. Number 1, 4y and 5xy are not like terms. One has a y only, and the other has both x and y, so they're not the exact same variables raised to the exact same power. Number 2, xy and -xy are like terms. The variables and their powers are the same. What's different is the coefficient. One has a coefficient of 1, while the other has a coefficient of -1. Number 3 is also like terms. Same variables raised to the same powers, their coefficients are different. And number 4, 5y and 2y squared are not like terms because the variable y is being raised to different powers. Combining like terms. When we simplify expressions by combining like terms, we add the coefficients but keep the powers the same. So 3x squared plus 5x squared is 8x squared. We keep the x squared the same and simply add the 3 plus 5. This works because of the distributive property in reverse. Another example would be -5c plus c, which would equal -4c. When you don't see a coefficient in front of a variable, it has a coefficient of 1. So -5 plus 1 gives us -4. Now you try. Pause the screen, and then you may resume when you're ready. Number 1, -9w cubed minus 3w cubed. We keep the w cubed. -9 minus 3 is -12. Number 2, 8cd plus cd. This has a coefficient of 1, so our answer is 9cd. Next, 4x plus 3 times the quantity of 5x minus 2. I treat this minus 2 as -2. Distribute the 3. 15x minus 6. Bring down my 4x. And now I can combine like terms. 4x plus 15x is 19x minus 6. For -5 minus 2 times the quantity of 3x minus 8, I'm distributing -2. This is the type of question when it's very important to circle this so I don't forget about that negative. -2 is being distributed to 3x and -8. So I get -6x plus 16 and bring down my -5. Combine the like terms, -5 and positive 16, so I get -6x plus 11. Distributive property in combining like terms. Try these questions on your own. Pause the screen and resume when you're ready. For number 1, we distribute 7 to 2h and to negative 3k. So we get 14h minus 21k. And we recopy the rest of the question. Next, I combine like terms. My 2h and my positive 14h become 16h. I can also combine negative 3k and negative 21k to get 16h minus 24k, our final answer. Number 2, I'm distributing negative 4 to both 2w and negative 3. Negative 8w plus 12, bring down my negative 8. Combine like terms, which are negative 8 and positive 12, to get negative 8w plus 4, our final answer. For number 3, distribute 4/5 to both 5x and 25. 4/5 times 5x over 1, I can cancel out my 5's by cross-reducing, so I'm left with 4x. 4/5 times 25 over 1, I can cross-reduce. 4 times 5 is 20. Recopy my 7x, and combine like terms. 11x plus 20. Which of the following expressions represents the perimeter of the figure? Well, we know that perimeter is when you add up the lengths of all the sides of the figures. In other words, 2a plus a plus a plus b plus b plus b plus 2a minus b over 2 plus 2a minus b over 2. I'm going to start to combine like terms. So I'll start with the a's. 2a plus 1a plus 1a gives me 4a. 1b plus 1b plus 1b gives me 3b. Next, for the 2a minus b over 2, I can think of that as being half of 2a minus b. So if I'm taking half of 2a minus b and adding it to another half of 2a minus b, I get 1 whole 2a minus b. So I can add 2a minus b here. Now I can combine like terms to get 6a plus 2b, which is answer choice C.